Lesson 9 is about rewriting equations of circles, and in 9.1 we're going to review how to complete the square, which is just one of the methods of rewriting quadratics. So example 1, rewrite each equation by completing the square, and this is going to be when a equals 1. So the steps you can see are on the right side, those are the ones I'm going to follow. So a is 6x squared plus 24x minus 18 equals 0. For these examples, we specifically want a to be 1, which a is like referring to standard form for a quadratic, which is ax squared plus bx plus c. So a is that lead coefficient, the number that's in front of x squared. So in the first problem, a is 6, so it's obviously not 1. So in order to get it to be 1, I have to divide the entire equation by 6. So divide everything by 6, every single term. 6x squared divided by 6 would become x squared. 24x divided by 6 would become 4x. And then negative 18 divided by 6 would become negative 3, and then equals 0 divided by 6 is still just 0. And then now we're ready for step 1. So step 1, rearrange the equation so that the variable terms are on one side of the equation and the constant term are on the other. So that means that this negative 3 needs to get on the other side of the equal sign. So in order to cancel it out on that left side, I'm going to add 3, and then I would also need to add 3 to the other side of the equal sign right there. So I would bring down the x squared, bring down the 4x, and then the negative 3 plus 3, that would cancel out, and then equals 0 plus 3, so 3. So we're done with step 1. So step 2 says add b over 2 squared to both sides of the equation to complete the square and create a perfect square trinomial. So that b in the b over 2 squared is referring to the b when it's in standard form, so that's the coefficient of x. So in this problem, b would be 4. So b is always the number in front of just like the regular x, not the x squared. So I would want to find b over 2 squared, so you can do it off to the side. So we'll do 4 over 2 squared, and then 4 divided by 2 is 2, and then we still have to square that, so that would be 4. So that 4 is what we have to add into both sides of the equation. So we'd have to add it right here to create that like perfect square trinomial. And then in order to keep the equation balanced, I would also have to add it to the other side of the equation. So it would be x squared plus 4x, and then after the 4x, I would add in that 4 that I got from b over 2 squared, and then equals 3, and then after that 3 I would add in the 4 over there as well to keep the equation balanced. And then now we're ready to move on to step 3. So step 3 says factor the perfect square trinomial as x plus b over 2 squared. So there's a couple different ways that we can do this part of the problem. So one is it's always going to factor into this like kind of little mini formula, x plus b over 2 squared, so it'll be x. And then b over 2, we have that number up here, it was 4 over 2, and it was just 2 once we simplified 4 divided by 2. So it's like the number that you had before you squared it. So since it was a positive 2, this would be a plus 2. So that's one way of approaching it. The other way of approaching it is there's kind of like a specific pattern that you can go by that always works out as well. I'm going to zoom in for this part since we don't really need the steps anymore. So this part of the equation will always factor into a binomial squared because what we just created by completing the square is a perfect square trinomial. So the pattern is you take the square root of the first term, so the square root of x squared would be x, and then you take the sign from the middle term, so since that's a plus, you would put a plus right here, and then you would take the square root of the third term, this 4, so 4, square root of 4 would be 2. So I'll run through that one more time, and again, you can still use like kind of the way that it was written in step 3, it's really just personal preference. So you take the square root of the first term, the sign from the middle term, and then the square root of the third term, and it'll always work out correctly. And then the reason that like, I guess, you don't have to write this part, but if I were to take this and try to FOIL it back, like x plus 2 squared means x plus 2 times x plus 2. If I were to FOIL it back, I would get x squared and then plus 2x plus 4, which would bring me back here. So a lot of times I get the question of like, what happened to this middle 4? And it kind of, it's not that it disappeared, it's just that when you factor it down into a binomial squared, you don't need to write it. Okay, so that x squared plus 4x plus 4 factors into x plus 2 squared, and then equals, over here we can add the 3 and the 4 together to get 7. And then for this section, this is just how we're going to leave our answer. So we're not solving for x, we're just rewriting it by completing the square, and it's building towards being able to rewrite equations of circles, because we know equations of circles have like x minus h squared or like y minus k squared in that formula. So we want to complete this squared just to pretty much kind of get like this part of x plus or minus something squared. Okay, so for B, I'm going to zoom out so we can see the steps again. Same exact type of problem, we're just going to run through it one more time. So for B, it's x squared minus 6x minus 21 equals 0. So first check to see if the lead coefficient A is 1, and in this case we don't see a number there, so that would mean that it is 1. So we're ready to move on to step 1. Rearrange the equations so that the variable terms are on one side and the constant term is on the other. So we have to get this negative 21 on the other side of the equation. So I can't just move it, I have to use inverse operations to cancel it out. So I would cancel out the minus 21 by adding 21, and then I would add it to the other side as well. So I would bring down the x squared minus 6x. The negative 21 plus 21 would cancel out, and then equals 0 plus 21, so 21. And then now we're ready for step 2. So add b over 2 squared to both sides of the equation. So b is referring to, again, like the b in standard form. So that's going to be the coefficient of just x to the first power. So b would be negative 6. So if I take that and put it into like b over 2 squared off to the side, it would be negative 6 over 2. Sorry, whenever I write my 6's, they kind of look like b's. But negative 6, that one looks even crazier somehow. Negative 6 divided by 2 is negative 3. And then we have to take the negative 3 and square it, and that gives us a positive 9. So we'd have to add a 9 in right here after the 6x, and then also after the 21 to keep the equation balanced. So it'd be x squared minus 6x, and then plus 9 right here, and then equals 21, and then plus 9 right here again, just to make sure the equation stays balanced, because if you add 9 to one side of the equal sign, you have to add it to the other side as well. Okay, so I'm going to show you how to factor both ways. I'll start with the way it's written in step 3 first. So step 3, factor the perfect square trinomial as x plus b over 2 squared. So it'll always be a binomial squared. And then b over 2 was negative 6 over 2, which was negative 3. So it's that number that we got before we actually squared it. So x, and then plus b over 2, but b over 2 is negative 3, so it'd be minus 3. And then equals, over here, 21 plus 9, so 30. So that's one way of factoring it. I'll show you the other way one more time. I'm actually just going to, like, not erase it, but go through and kind of show, like, how each would become the correct value. So you take the square root of the first term. So square root of x squared is x. You take the sign from the middle term. So since this was a minus, that would be a minus. And then you take the square root of the third term. So since the third term was 9, the square root of that would be 3. So x minus 3 squared. So it really doesn't matter which way you factor it. You'll end up with the correct answer either way. So just do whatever you feel most comfortable with. So x minus 3 squared equals 30. And again, we're just stopping here because we're not solving. We're just trying to rewrite the equation by completing the square, basically to try to get this structure in the equation so that we can start working equations of circles into standard form. Okay, so moving down to 9.2, this is rewriting equations of circles. So before we get into this section, 9.2 in your workbook did have like a full set of written instructions, kind of like 9.1 had those off to the right. The instructions were pretty wordy, so I put them here if you want to screenshot them and reference them later. I'm not going to reference them just because sometimes I feel like when we get too bogged down in steps, it kind of does more harm than good, but just know that these are here if you would like. So for example 1, rewrite the equation x squared plus y squared minus 12x plus 8y plus 27 equals 0 into standard form for a circle, which standard form is x minus h squared plus y minus k squared equals r squared, where h and k are the center of the circle. So our first step is exactly the same as in 9.1, where we want to get all of our terms that have a variable on one side of the equal sign and our constant on the other. So in this case, our constant is 27. So I want to cancel that out from the left side. So I would subtract it to cancel out the positive 27. And then I also have to subtract it from the other side of the equal sign as well. So that's where I'm going to start. So it'll be x squared plus y squared minus 12x plus 8y equals, the 27 minus 27 cancels out, and then equals 0 minus 27 is negative 27. And then now my next step is going to be to kind of regroup the terms together, like x's with x's and y's with y's. And I want to kind of treat them as if they're on their own little mini standard form, where the x squared would come first and the y squared would come first and for the y's. So what I mean by that is, like, there's an x squared and a negative 12x. I'm going to group them together and make sure that I put the x squared term first and then the minus 12x term second. And then for the y's, I'm going to group the y's together, so y squared and 8y, making sure I put the y squared one before the 8y. So y squared plus 8y, and then equals negative 27 on the other side. Okay, so this order is really important. For any problem like this, you'll want to get your equation in this exact order. So the order is, you'll put your x group first, and you'll have the x squared term first and the x to the first power term second. And then the y's would be next, and you would put the y squared part like first in terms of the y's, but maybe like third overall. And then the 8y, or really just like the y to the first power, would be in the fourth spot, and then the constant would be on the other side of the equal sign by itself. And if you wanted to number that, it would be like in the fifth spot. So you always want to reorder it in this way. And then now to get our equation from here to standard form, notice the standard form has like x minus h squared or y minus k squared, like a binomial squared. And I'm going to scroll up for a second because we ended up with something like that in our answers down here when we were completing the square. So that's what we're going to have to do for like changing it into standard form for a circle, is complete the square. But notice, like, here we only got one, like x minus 3 squared. We didn't have two different ones like there kind of is in standard form for a circle. And notice that we have like one for the x's and one for the y's. That means that we're going to have to complete the square once with the x group and once with the y group. So I'm going to rewrite this equation. I would wait until you see how I rewrite it, because I'm going to kind of add in some spacing. So I'm going to leave a space after the x's, and then I'm going to leave a space after the y's as well, because we're going to complete the square once with the x's and once with the y's. So we're going to add in those kind of extra new numbers into like that spot after the negative 12x and after the 8y. So this is kind of going back to like step 2 from 9.1, where we had to add b over 2 squared to complete the square. And that's what we want to do here, because we want to create a perfect square trinomial so we do get that binomial squared when we factor it. So up here, that b from b over 2 squared, that was the coefficient of x. And its b is always going to be like the coefficient of your variables to the first power. So even though in our new problem we have like an x and a y, b is going to be the coefficients of x to the first power and y to the first power, as opposed to x squared and y squared. So our like b's for this problem are going to be negative 12 and 8. So always just the coefficient of like your x to the first power and your y to the first power. So I'm going to do the x's first. So b will be negative 12. So it'll be negative 12 over 2, and then we'll have to square it. So negative 12 divided by 2 is negative 6. And then if we square it, we get positive 36. So I would add in a positive 36 right here. And then I can't just like add in a number to the equation, it's going to throw it off balanced. So if I add a 36 over there, I also have to add it to the other side of the equal sign. So I'd add it to the right side as well. So what I just did is I created a perfect square trinomial for just the x's, and I will be able to factor it, but I'm going to go ahead and repeat that same process for just the y's now. So now, since I'm dealing with my y's, my b is going to be 8. So it'll be b over 2 squared equals 8 over 2 squared, since 8 was the coefficient of just y. And then 8 over 2 is 4, and then 4 squared is 16. So 16 is what we're going to add into our y's, so plus 16 right here. And then same thing, if I like add in a 16, it's going to throw the equation off balance. So I have to add it to the other side as well to keep the equation balanced and like keep the same solutions essentially. Okay, so one thing I want to add before we move on to the factoring part. So if you get really comfortable with the like b over 2 squared, I don't necessarily need you to like write this whole process out. If you say like, okay, well, b is negative 12. If I divide it by 2, that's negative 6. And then if I square it, I get 36. Or 8 is b over here. If I divide it by 2, it's 4. And then if I square 4, I get 16. So whatever you're comfortable with, write as much or as little as you need to. And then with the y's, we just created another perfect square trinomial. So we're going to factor each of these separately. So the x is the green group, the y is the purple group. So because they're both like were created by completing the square, we know they're both going to factor into a binomial squared, which means 2 terms squared. And then same thing with the y's, they'll factor into a binomial squared. And I'm going to use just the pattern to factor this one. So it'll be the square root of the first term. So the square root of x squared would be x. The sign from the middle term, so minus. And then the square root of the third term, so the square root of 36 is 6. And then the same pattern for the y's, the square root of the first term, so y. The sign from the middle term, so plus, since it was a plus 8y. And then the square root of the third term, so the square root of 16 is 4, so y plus 4 squared. And then now I just need to add these 3 numbers together, so negative 27 plus 36 is 9, and then 9 plus 16 is 25. And then now all of a sudden we have like x minus a number squared, just like the x minus h squared. We have a y plus 4 squared, but that just means our k is going to be negative, so y minus k squared. And then we have our radius squared over there. So we have it in standard form. I'm just going to kind of rewrite it so it's all in one color and not all kind of spaced out weird. But it'll be x minus 6 squared plus y plus 4 squared, and then equals 25. So this is the equation of our circle in standard form. And then now I just want to go ahead and state what the center and the radius are. So remember, for the center of the circle is supposed to be the point HK. So if I want to figure out what h is, that's in the parentheses with the x. It's x minus h. So since I have an x minus 6, h is going to be 6. So the first coordinate in my point is going to be a 6. And then for k is in the parentheses with the y, it's y minus k. So since I have a y plus 4 here, remember it's kind of like the opposite of what it looks like it should be because of that minus in the formula. So k would actually be negative 4. Because if I were to put negative 4 in here, it would be like y minus negative 4, and it would turn it into a plus 4 just like we have in our equation. So k is negative 4, so that'll be the y coordinate for our center. And then for our radius, remember that this value is not our radius, it's r squared. So if this is like r squared, I can think of it as like 5 squared. So that would mean that the radius is 5. Okay, so that number at the end, that 25, is not the radius, it's the radius being squared. So since 5, why did I write 4? Sorry, okay, so the radius is 5. But yeah, so that number at the end is not just the radius, it's the radius squared. So since the number at the end is 25, and 25 is 5 squared, the radius must be 5. So equation of our circle is x minus 6 squared plus y plus 4 squared equals 25. And then our center is at 6, negative 4, and our radius is 5.